In this video, we're going to look at solving linear systems using a method called elimination. In our first example, we're going to solve the system x plus 2y equals 8 and y equals 3x minus 2. The first step in elimination is to express both equations in the form ax plus by equals c and then label them a and b. So let's start there. So we have x plus 2y equals 8. That is already in the correct form, so I'm going to call that equation A. If you look at the second equation, y equals 3x minus 2, the 3x is on the right side, so let's bring it to the left side. So I get negative 3x, because I subtract 3x from both sides, plus y equals negative 2, and that is equation B. Second step says to multiply the equations so that the coefficient of x or y is the same in both equations. So we have two options. We can either multiply equation A by negative 3 so that the coefficient in front of the x is negative 3 for both A and B, or we can multiply equation B by 2 so that the coefficient in front of y is the same. I'm going to go with the first option for this example. So I'm going to take equation A, I'm going to multiply everything by negative 3. If I do that, I get negative 3x. Then negative 3 times 2y is negative 6y. And then 8 times negative 3 is negative 24. Next, I'm going to rewrite b below a times negative 3. And then I need to decide, do I add or subtract these equations to eliminate one of the variables? Well, if you look at it, since the coefficient in front of x is the same, I will need to subtract the two equations, and I'll show you why. If I have negative 3x and I minus a negative 3x, I get negative 3 minus negative 3, which is the same thing as negative 3 plus 3, which is the same thing as 0. So here I end up with a 0x. We don't need to write that, we can just leave it blank. Next is negative 6y minus 1y. So that's going to give us negative 7y's equals negative 24 minus negative 2, which is negative 24 plus 2, which gives us negative 22. So for this first example, we have negative 7y equals negative 22. We need to isolate for that variable, so we divide both sides by negative 7. Recall that two negatives give us a positive, so we end up with y equals 22 over 7. There is the y value. That is our fourth step when following elimination. Solve for x or y. The fifth step is to take this value and sub it into a or b and solve. So we choose, do I want to use equation A or do I want to use equation B? So let's just pick one of the equations. We have y equals 22 over 7, so let's use equation A. So I'm going to sub y equals 22 over 7 into A. And if we look at equation A says we have x plus 2y equals 8. So I have x plus 2y's, but we know that y is 22 over 7 equals 8. Recall that 2 is a fraction, it's 2 over 1. So I have x plus 2 times 22 is 44. 44 over 7 equals 8. Let's keep going. So x equals, I'm going to bring the 44 over 7 to the other side. 8 minus 44 over 7 because we're going to subtract 44 over 7 from both sides. Remember, 8 is a fraction, 8 over 1. Next step is to find a common denominator so we can finish the subtraction. So I have equivalent fraction for 8 over 1 would be 56 over 7. And then we're going to subtract the 44 over 7. And if we do 56 minus 44, we end up with 12 over 7. So now we have the x value. We have the y value. So that means we know the point of intersection. So therefore, xy equals 12 over 7 and 22 over 7. The last step is to verify. And notice we say verify the original equations, so the ones we started with. So let's go down to here. So we're going to make 2 verification charts to check our work. And if we look back here at the top, we're looking at these 2 equations up here. So we have x plus 2y equals 8. So I'm going to go x plus 2y. We know that equals 8, or should equal 8. And then we have y equals 3x minus 2. So y is on the left side. 3x minus 2 is on the right side. So let's sub in these values. So x is 12 over 7 plus 2 times 22 over 7. So remember, that's 2 over 1. So the first thing we do is multiply the 2 fractions. So I get 12 over 7 plus 44 over 7, which gives us 12 plus 44 is 56 over 7. And if we divide 56 by 7, we get 8. So this does fit on the first line. So let's check if the point is on the next line. So the left side is y, so we have 22 over 7. And then on the right side, we have 3 times 12 over 7 minus 2. Again, remember that these are all fractions. 3 times 12 is 36. 1 times 7 is 7. And let's change the 2 over 1 to a common denominator. And our common denominator is 7, so that would be 14 over 7. And notice we do 36 minus 14. That gives me 22 over 7. And this works as well. So we have verified that this is indeed the point of intersection for this linear system. All right, let's go on to the next example and practice this a few more times. So solve each using elimination. So let's go through all those steps again. First step, rewrite it as ax plus by equals c. So let's start with the first one. That's 3x plus 2y. I need to move the negative 2 over, so add 2 to both sides, so I get 2. And same as the one we had above, the 5x is on the wrong side, so I get negative 5x plus 4y equals negative 18. So these are equations A and B. So again, we have 2 options. We can eliminate x or eliminate y. And in this one, eliminating y is a little bit easier, because all I need to do is take that A equation and multiply it by 2. If I multiply this equation by 2, the coefficient in front of y will be the same. So let's do that. So if I take A and multiply it by 2, I'm going to end up with 6x plus 4y equals 4. If I rewrite B below this, I get negative 5x plus 4y equals negative 18. That's equation B. And I see that since these have the same coefficient, if I subtract them, I'm going to get 0. So I'm going to eliminate the y variable. But let's go through the rest. I have 6x's minus negative 5x's since I'm subtracting. And 6 minus negative 5 is the same thing as 6 plus 5, which means I have 11x equals, let's keep going. I have 4 minus negative 18. 4 minus negative 18 is 22, because it's 4 plus 18. Next is divide both sides by 11. And we see that we end up with x equals 2. Now we need to pick an equation to sub this into. So I'm going to sub x equals 2 into a or b. So let's say I pick b. So that means I'm going to get negative 5. The x is 2 this time, so negative 5 times 2 plus 4y equals negative 18. Negative 5 times 2 is negative 10. Plus 4y equals negative 18. I'm going to add 10 to both sides, so I'm going to get 4y. So if I add 10 to both sides, negative 18 plus 10 leaves me with negative 8. I'm going to divide both sides by 4. And that gives me that y is equal to negative 2. So now I have the x value of 2, and I have the y value of negative 2. So we can conclude and say that the intersection xy is equal to 2, negative 2. So this is the point where the two lines will intersect. And of course our last step is to verify. And this is always an extra step just to check your work. And remember to always verify your original equations. So at the top, we see we had 3x. We see we had 3x plus 2y minus 2, and that equals 0. And then we had 4y equals 5x minus 18. So now let's use the point that we have 2 and negative 2. So we have 3 times 2 plus 2 times negative 2 minus 2. 3 times 2 is 6. 2 times negative 2 is negative 4. And the negative 2 is still there. And then we have 6 minus 4 minus 2, which is 0. Done. Again, the y is negative 2, so that's 4 times negative 2, which is negative 8. Now let's check the right side. That's 5 times 2 minus 18. That's 10 minus 18, which is negative 8. We have shown that this is the point of intersection for the following linear system. All right, last one. Notice these two are already in the correct form, so right away I'm just going to call them a and b. Now pick a variable that you think you can eliminate. You can choose x or you can choose y. In this one, I would choose the y just because the values are smaller. And notice in this case, I'm going to have to actually multiply both equations for this to work. So to eliminate y, I'm going to do this one a little bit differently. I'm going to multiply a by 3. And you notice I get 9x minus 6y equals 6. And instead of making it the same, I'm going to multiply b by 2. And notice in this case, I'm going to get negative 20x plus 6y equals 16. Now normally I'd say subtract, but if you look at this closely, if I subtract these two, I'm going to get negative 6 minus 6, which does not equal 0. In this case, I can actually add these two. Because if you think of it this way, I'm going to have negative 6, and if I add 6 to it, that does give me 0. So if I do addition, I need to add everything as I go across. So let's go through this. For the x's, I get 9 plus negative 20. So for that, I'm going to end up with negative 11. 9 plus negative 20 is negative 11x's. The negative 6 plus the 6 is 0, equals 6 plus 16, which is 22. I now divide both sides by negative 11, and that gives me that x is equal to negative 2. Next, I'm going to sub x equals negative 2 into a or b. So this time I'm going to pick a. And a is 3 times x, so 3 times negative 2, minus 2y equals 2. 3 times negative 2 is negative 6, minus 2y equals 2. I'm going to add 6 to both sides to get rid of the 6, or negative 6, sorry. So that's going to give me negative 2y equals 8. I'm then going to divide both sides by negative 2. And that's going to give me y equals negative 4. So we see that the point of intersection is going to be x equals negative 2, y equals negative 4. So therefore, xy equals negative 2, negative 4. Last step, let's verify our work. And again, start with the original equations. So if we go back above and look, I know that they are 3x minus 2y is equal to 2, negative 10x plus 3y is equal to 8. Let's use our point and see if it's on both these equations. So we get 3 times negative 2 minus 2 times negative 4. 3 times negative 2 is negative 6 plus 8. And negative 6 plus 8 is 2. Good. Negative 10 times negative 2 plus 3 times negative 4. That's 20 minus 12, which is 8. And we have shown that this point is indeed a point of intersection for this linear system or the solution. And we are done. Here are some questions for you to try, and if you have questions, please contact me.